Hello, and thank you for joining us for ShipIt number 11. Today, it's Making Commerce Extensible with WebAssembly. ShipIt is our monthly virtual gathering where we bring together engineering shop folk so we can talk about the things that we're working on and take questions from all of you that have decided to join us today. ShipIt is a way for us to connect with you directly in our digital by design world. My name's Anita Clark. I'm the Senior Managing Editor at Shopify, and I run our engineering blog. Today, we're talking about our work with WebAssembly and what that means to our partner ecosystem. My guests today are members of the team building a developer SDK using AssemblyScript and Lucid that will allow partners to write synchronous plugins to our commerce platform. We're taking questions at the end of this presentation, so please use the Q&A function in the chat and we'll get to your questions after the presentation. I'm really excited to hear what's going to happen with WebAssembly today, so I would like to introduce you to all our guests. Thank you for being here.
Hey everyone, I'll introduce myself first. My name is Mitch Dickinson and I'm an engineering manager. I work on the Shopify scripts team. I've been working on this WebAssembly-based solution within Shopify for a couple of years now, and I'm super excited to be here today to share what we're doing.
Hey, I'm Duncan Yusuke. I'm a developer on the scripts team. Been on it since the start for about 2 years, I think.
Hey everyone, my name is Saul Cabrera and I work on developer experience on Shopify scripts. I've been on the scripts teams for around 6 months now.
And hey everyone, my name is Maxime Bedard. I'm based from Montreal and I've been on the scripts team for roughly around a year. And I'm working on the platform team for scripts, and I've been working on the actual runtime. And I'll be around to answer some of the questions at the end. I'll hand it off to you, Mitch.
Cool, great. All right, let's get going. So for those who don't know, at Shopify, this is our mission. So our mission statement is to make commerce better for everybody. And we're not exaggerating when we say everyone. We mean everyone in the global sense. And to make commerce better for everyone, we need Shopify to service more industries and countries around the globe so that every human on the planet can have a better commerce experience. But to make commerce better for everyone, there's a lot of diversity in commerce globally, different industries, markets, geographies, different stages of growth. And Shopify is just a single multi-tenanted software as a service solution. It's one code base. It's impossible to solve for all of commerce in just a single code base. Even with 100 times the developers on payroll, it couldn't be done. And so plenty of enterprise software companies try to tackle this problem in a single product. And the product experience often ends up feeling a little something like this. The more features become available to customers by default, the more difficult it is to use any one feature individually. And at Shopify, we want to make the most flexible and powerful commerce platform out there, but avoid this common trap. So take something like iOS. It's an easy to use out-of-the-box experience with some default apps like the phone and the browser that work for most people. But it also comes with an amazing app store which people can use to customize the platform to suit their personal needs. And third-party app developers can build things just as amazing as the first-party developers can who work at Apple. And we think at Shopify that this platform approach is the only way that Shopify could possibly solve for the everyone in our mission. And we do that by enabling the ecosystem to build solutions for merchants' diverse needs, so third-party app developers. And here you might say, well, doesn't Shopify already have an app store? And yes, we do. So Shopify does have an app store today with many thousands of apps, lots of partners writing apps for Shopify. So then why are we here at all today if this exists? Aren't apps the solution to this complexity problem? And they sort of are. But there's a few key limitations with the model as it exists today in Shopify. Firstly, we have an obvious distinction between first party and third party when it comes to developing on Shopify, which gives an unfair advantage to our first party developers internally. So for example, Shopify devs can write code directly into our commerce product's private code base, but apps have to talk to Shopify through the API. And this means app developers can't innovate for the niche markets they service with the same quality and flexibility of tooling that Shopify developers use. And since apps run elsewhere outside of our infrastructure on their own hosted solution, and they talk to Shopify over the network, there are performance and scale issues with third-party apps that can't meet the scale demands of a large flash selling merchant. Finally, since apps render their UIs through iframes in the app section of Shopify, for the most part, there's an experience quality gap between first-party features and third-party apps. And so here what you're looking at is an image of the apps list within one of my test stores in the Shopify admin. So you can see in the center there, these are all the apps that I've installed in my store. When I click one of those apps, the area in the green box here is loaded from the app server or the CDN, and it's rendered inside of an iframe through Shopify's app bridge. And the app backend talks to Shopify's backend using HTTP APIs. The result here is a slower and more coarse-grained Shopify customization and a less consistent product experience. And today, this is why. So Shopify is a commerce product with web-based APIs that apps running elsewhere can use to talk to Shopify. But what we really want is more like this. So I've kind of edited the statement here, crossed out some stuff. There's a lot here, so let's unpack it a little bit. So here we have, Shopify is a highly extensible commerce platform with developer tools that apps running on or off the platform can use to customize Shopify. That's kind of what our vision that we're going to discuss today is all about, is this evolution from product to platform. We want to permit some apps to run right on the platform. If an app consists of just simple extensions and business logic, there shouldn't even be a need to run an app server. And we want to provide developer tools to make this possible as a native part of the Shopify developer toolkit, which is delivered through the Shopify app CLI. And so the rest of this talk, you'll learn a lot about what we're doing, and it's going to focus on this capability to bring app logic into Shopify, and we're doing that through the amazing properties of WebAssembly. And I'm going to hand it over to Duncan.
All right, thank you, Mitch. So first, I just want to cover why it's so important to have that logic running on the platform rather than off. So first, I'm going to run through a merchant app interaction model. So how apps are typically work today. We'll have a merchant. The merchant's going to interact with the partner web server directly. And this is infrastructure that the partner hosts themselves. Maybe they've spun up some kind of Heroku server or something small, because web server is the only way that they can actually interact with Shopify. Now, at this point, the partner web server is probably going to go and request some shop data from the monolith. So maybe it needs customers or products, something like that, to do whatever logic. Now it's going to experience some delays due to internet latency, because these are two just sort of arbitrary places on the internet. There's going to be a delay between them. Eventually, we're going to return some shop data back to the partner's web server, and then they're going to be able to respond to the merchant. And the merchant might not be too happy about this, but they're probably going to stick around and wait until they get their response. But now suppose that we have a partner-developed app which gives a 10% discount on a buyer's birthday. What if we reapply the same model? So first off, we start off with a buyer, and they're going to check out. And checkout lives on the Shopify monolith, so that's what they're going to be contacting first. Now, the Shopify monolith, in order to answer the question, how should this active checkout be discounted, it's going to have to reach out to the partner server, which is just somewhere else on the internet. And then we're going to suffer some delays due to internet latency that we can't really control. And eventually, we're going to return 10% off all items to the monolith, but it's too late because the buyer has actually abandoned the checkout. In e-commerce, every millisecond reduces conversion and ultimately reduces the amount of money our merchants can make on the platform. And there's an even worse case. So suppose we have some sort of flash sale. A merchant has said, you'll get 50% off all of your products if you arrive at a certain time. So the buyers appear in huge numbers. They all check out, sending tons of requests to Shopify. That's not a problem because Shopify is built to scale to handle lots and lots of customers. This won't be an issue. But then we turn around and we say, okay, now we need, for each of these checkouts, we need to know what the discounts need to be. So we'll go ask the partner. We'll send tens of thousands of requests to the partner. But the partner, their infrastructure isn't built to handle this. They don't have the money or the expertise or the time to build infrastructure that scales the same way Shopify does. So what happens is the partner server goes down. Now nothing is returned. And all the monolith can do is just continue the checkout without the discount. But then the buyer's looking at their checkout and they said, I came because I wanted a 50% discount. Now you're not offering it to me. Not only are they not going to buy it, they're also going to be a little annoyed that the merchant wasted their time. So to recap, in buyer-facing flows like a checkout, we can't afford the added latency, and partners can't always handle the added traffic. So instead, we're adding a code execution intermediary, which works something like this. we have a partner, and way ahead of time, they're going to push up some code into the Shopify cloud. That's going to be loaded up onto the code execution engine for use later. Then we're going to have the buyer. They're going to check out just like before. They're going to contact the monolith. But now when we ask, how should this active checkout be discounted? That request isn't going across the internet. It's happening within our cloud. So it goes to the code execution engine. We execute it. Then we return 10% off all items, and everything works out. And because we control the code execution engine's infrastructure, we're confident that it's not going to go down, regardless of traffic. Let's zoom in a bit on the on this execution engine and talk a little bit more about how it works. So the execution engine is responsible for storing and executing untrusted code because we don't have the same level of trust with our partners that we do with internal Shopify developers. The engine is an HTTP server that we've implemented in Rust using Tokio. It uses a reactor model with 2 thread pools, one for handling the HTTP requests and another for executing code. On the right here, we can see a graph that shows the availability of our threads for executing code going down during a large sale. But before we continue to talk about what the engine does, we need to talk about the format of the code that's submitted and is executed, which is, of course, WebAssembly. So I'll be passing it off to Saul to talk a bit about that.
Thanks, Duncan. So in order to understand how our execution model works, it's important to understand what is WebAssembly, and I'm going to do a very brief introduction to WebAssembly here. In order to do this, I'm going to rely on the official definition of WebAssembly. WebAssembly is defined as a binary instruction format for a stack-based virtual machine. There are 2 concepts that stand out here. The first one is that the instructions are targeted to a virtual machine. That means that they're not tied to a specific processor. The normal process to execute WebAssembly code is to load the binary into a runtime, like runtime engine in our case. Then that runtime is responsible for generating the actual machine code, and then that code is the one that's executed to perform the logic that the developer is submitting. That code generation can be done ahead of time or just in time. That's just an implementation detail, but I guess the important part is that code gets generated at that stage. The second concept that we need to explore is the stack-based property of the virtual machine. So there are normally 2 types of virtual machines, stack-based and register-based. Register-based machines operate on registers for the specific processor, and they are normally limited. On the stack-based model, all the operations act upon the operands that are on the stack. So in this example, if we have a stack that has 1 and 2 at the top, and we apply the i32 add operation, this operation will go and grab 1 and 2, apply the operation, and put 3 on top of the stack. There are 3 main reasons to go with a stack-based machine for WebAssembly, and they are a small binary size, efficient instruction coding, and portability. Now, the third concept that is important, and I think this is the most crucial concept to grasp about WebAssembly, it's its memory model. This model allows isolation of the guest module. That means the code that is submitted by a third-party developer from the host model. In this case, our host is our runtime. So this means that the guest has access to a specific array of contiguous bytes that are given by the host, but it can't access any of the host's memory. This makes a WebAssembly module totally a sandbox to the hosting environment. So with this, I'm going to give it off back to Duncan.
Thank you. So what do we do with the WebAssembly code once we get it? Our code is compiled and executed using a tool called Lucid. Lucid compiles our code ahead of time and also provides a VM for executing that compiled code. It's important to us that we compile the code ahead of time because, as we mentioned before, every millisecond during a buyer-facing flow like a checkout really counts to conversion. So even if it takes the partner a little bit longer to compile their script and upload it, that's going to be a trade-off that we take. Here's the rough process for uploading code. we start off with some untrusted code sent by a partner in the form of Wasab bytecode. Then we upload it to like a long-term storage, which we need sometimes in case we need to recompile the code. Then we go through our Lucid ahead of time compiler. That's going to produce some executable machine code. We're going to put that in 2 tiers of caches. Our first tier is in memory and uses an LRU scheme. The next tier is memcached, and that is a little bit less strict in terms of size. Then when we're executing code, we're going to start with a request to run the code in a given input. We're going to go through the various levels of caching, possibly recompiling the code if we have to go all the way to long-term storage. Then once we have our executable machine code, we're going to wait for an available Lucid VM or equivalently a thread in the executor pool. Then we're going to load our input into the memory of the module, run the module, extract the memory from the module as the result. Here's some key performance indicators when it comes to performance on the engine itself. We have our memcache and GCS lookups. So for performance to really get maximal performance, we need our scripts to always be in memory before the request is made, which is sort of an interesting data locality challenge. Here in this chart, you can see that we've had a number of memcached loads on the 17th. Now, and if you have to go all the way to GCS, that's even worse, because then we actually have to recompile the code. Like, not only do we have to call GCS, we also have to recompile, so it becomes quite slow. Now, for executor worker availability, this is about how long we have to wait to get one of those VMs so that we can run some code. Here we can see how the threads become less and less available. Each line here is a different instance. This was during a large sale. And then an equivalent stat, but sort of a different perspective, is the module execution queuing time. So how much time do we perceive that we are waiting for a thread to execute? And we can see it's not terribly consistent between different instances. In terms of performance goals, we have to remember that time spent waiting for code to run reduces conversion during a checkout. So that's what we're working towards, is always about increasing conversion by reducing load times. And also we have to recall that a single checkout could involve several scripts. So in my earlier example, we talked just about a discount script, but there might actually be 3 or 4 scripts. Maybe there's one that determines what your shipping options are. There's one that determines if you're a bot, so on and so forth. So it adds up linearly. And it's important that merchants shouldn't need to make the trade-off between customizability and performance. And when the merchant decides, I don't want my Affirm payment method to appear to someone who isn't allowed to use it, they shouldn't be thinking, but how is that going to impact how it loads in the checkout? It should be negligible. Let's see how we're doing on that front with our performance numbers. This is from a February 17th load test. We had 7 million requests to the engine over 5 minutes. And we peaked right at the start with about 4.4 million requests per minute. We'll start with the latencies. Particularly the monolith perceived latency is very important, because this is how much time it takes from the perspective of the monolith to run a script. And it includes the network time. So as you can see, right at the start, we spiked all the way up to about 50 milliseconds and then went back down, hovered around 20. Then if we look at our engine time to respond, sort of from the perspective of the execution engine itself, how long it took to process the request, we can see it only spikes up to about 9. So really what we're facing here is an infrastructure challenge. When we think about optimizing a code execution engine, we think about how fast we can execute scripts. But in our case, that's not really the issue. As you can see here, we're executing scripts within about 2 milliseconds, even at the height of traffic. Whereas we can look at another part of our infrastructure, which was causing latency, like our ingresses, which determine which instance of the engine to use. We can see how once we start hitting big load on the engine, the autoscaler is kicking in, and it's trying to create more and more instances of the ingress just to handle the traffic. So there's parts of the infrastructure that are actually buckling well before the engine itself is buckling. For further optimizations, we plan on setting up a separate ingress, which will have longer lived connections. We're also going to be using a forward proxy that lives in the Shopify monolith that'll manage the connection with those ingresses. And I'll leave infrastructure there for today, and we'll go back to Saul to talk a little bit about language selection.
So one of the most important things to consider when enabling customizations through code is programming languages, especially in a very small and niche environment like WebAssembly, because it's one of the main tools to enable customizations in Shopify the way we have described it. So one of the main questions that come around this subject is people asking, how can I compile a program written in my favorite programming language to WebAssembly? And in order to answer this question, we need to take a look to one main factor. There are several, but we only take a look to one. And this is, how does your favorite programming language performs compilation? And here, the main example is, we're taking programming languages that compile to a bytecode for a particular virtual machine. We think that this use case is specifically challenging because this means that that virtual machine is responsible for the execution and optimization of the bytecode generated by the compilation of that program. So that means that there needs to be a mechanism of either compiling that virtual machine to WebAssembly or replicating the same functionalities of that specific language so that it can compile to WebAssembly. We're going to see what are the routes to get one of these programs compiled to WebAssembly. So the first option is to, as I already mentioned, to compile the virtual machine into WebAssembly and then load programs written in that language on that WebAssembly compiled virtual machine. Here, the disadvantage is that there are probably performance overhead because you will need to initialize that virtual machine and then execute your code. On top of that, your final WebAssembly module will probably be very big. There are already experiments around this with duct tape or QuickJS where these engines get compiled and then programs are loaded on top of these engines. The second option is to compile the actual bytecode generated from the compilation of that language to WebAssembly. This might be challenging depending on the coupling between the bytecode and the virtual machine. But there are already some attempts to do this. There is a project called JWebAssembly, which does this exactly. The third option is to create a new programming language with the same features as the original programming language, but only specifically for WebAssembly. This represents a very high effort, and you'll probably not get the same performance results initially. This is done right now by Lumen, which is a runtime and compiler for the Beam, which is the virtual machine for Erlang and Elixir. Now, this is a list of the languages that are available today. Each of these, they use several techniques that we saw before, but in our opinion, the list is not as important as the use case spectrum. Depending on your use case, you might want to choose one language that does one thing one way or another. Depending on this, you will get some advantages, and you will have to go with some trade-offs. Some trade-offs on one end are languages that try to, be as compatible as familiar languages, but their ecosystem and community will be a bit immature because they are new, or they will provide an incomplete developer experience. And on the other side of the spectrum, you have languages that have full compatibility with WebAssembly, but their learning curve might be a bit steep. In this case, this will be Rust, for example. At Shopify, we use AssemblyScript, at least internally for now. We haven't released any public tools in AssemblyScript yet, mostly because it generates efficient and small binaries. It is intended to be familiar to TypeScript, even though we have found out that it has some rough edges that doesn't make it 100% compatible. And the third reason why we chose AssemblyScript is because its tooling is easy to get started with, as it leverages most of NPM's ecosystem. So yeah, with this, I guess, thanks for tuning in. This was our presentation.
Oh, thank you. That was really awesome. Let me increase our heads a little, although I'm cutting off that arrow, but that's okay. I think our faces are more important. So that was great. And we're going to get into the questions because they're flying in. Remember, you can put your questions in the chat. select the little round button to identify it as a question for us, and we'll be wrangling them for you and getting these guys to tell them everything that they know. So let's start with the first one. How many milliseconds before a user notices latency?
Well, I think it's, sorry, go ahead.
I was just going to say, I assume this means like the end user going through the checkout, and I think that would be a function of like how long it normally takes to load a checkout page in Shopify versus how long it takes to execute this little unit of partner code. Keep in mind that partner code is really producing a kind of a relatively small portion of the overall kind of request for that checkout page. In the case of, say, discounts, it's computing some discounts. But there's a lot of other things that are happening on Shopify's backend in this single workload. So I think really we want to keep our system's execution latency as minimal as possible so that we don't affect the overall latency of the request. As far as when a user would notice, I don't actually have data on this. I think it would be a function of how long those checkout requests on average take relative to how large the latency is for the WebAssembly execution component. So I don't know if anyone has data around like checkout performance to speak to that, but yeah, that's kind of my first crack at an answer anyways.
Duncan, did you want to add to that, or do you feel that was
no? That's I think I might just say that, yeah, with the checkout, it's a matter of a lot of raindrops and a flood. So I think this is a matter of, we're well past the point at which you can notice the latency of loading a checkout. To what extent that is caused by scripts right now is quite minimal, but it could eventually be significant if we have, say, 12 scripts running or something like that.
Okay, great.
I'll just add one more comment, which is just that. Sorry, Anita.
No, go for it. We want your brain to come out. So please.
Yeah. Well, there's not much in there, but I'll try. Yeah, I'd say that in general, with this solution of extensibility, we want to keep the latency of partner code really, really minimal so that it doesn't matter what kind of Shopify workload is kind of wrapping around that execution. It's not going to impact that. So we do have some pretty aggressive latency SLOs, and it's why we've made the decisions we've made, because we really have optimized for performance here.
Awesome, thank you. Okay, our next question. Is the Ingress for the executor hosted in Kubernetes for the auto scaling that was mentioned before?
I guess I can answer to that. So right now we do. Like, it's all hosted in Kubernetes, even the engine itself. They're all distinct services, and core essentially just connects to an Ingress, and then we have an upstream pool that is the actual executor where we route the traffic to. There's a bunch of different alternatives that we're looking into. So like the forward proxy that Duncan was mentioning is one thing. We could potentially as well do some sort of like consistent hashing from the client, where each of the client would know which executor to connect to. There's a bunch of different strategies, but right now, like, this approach has worked fairly well. So we stuck to that one for now. So yeah, I hope it answers it.
No, thank you. Okay, our next question is, will any partner apps require refactoring or rewriting to work with the execution engine architecture?
I can try to take a crack at that one, and then others can chime in. I would say in general, this solution is a net new solution for our partner ecosystem. This kind of solution allows for very deep extensibility within Shopify, running custom business logic right inside the deepest internals of our system, which is not something that's really possible or has not been possible until now, at least in a broader sense of the scope of it. So I would say in general, no, there won't have to be much rewriting. This will be a new superpower that apps can use to do more and more powerful things on Shopify. If those listening are familiar with the script editor app that is available to Shopify Plus merchants, there are partners that help merchants write scripts, and those partners may want to look at exploring this new technology over time, because it will ultimately, provide a new version of doing what script editor can do today. But that's to my knowledge anyways, a smaller subset of the overall partner ecosystem.
Okay. Oh, sorry. Go ahead.
Maybe one thing I could add as well is like if you have like existing code that has like a WebAssembly compiler, you could potentially compile some of the existing code that you have into WebAssembly and then run it on our platform, right? So like it's essentially aimed to be built in a way that we can like enable you to reuse some stuff, but like obviously there won't be like everything won't be compatible with it, but some of the things will potentially enable this kind of like reusability of some of the business logic. So
great. Okay, the next one is, do you see partners eventually running client-side WASM? Is that the correct way to pronounce the acronym? Awesome. So sorry, I'll repeat that. Do you see partners eventually running client-side WASM? And a second part to this question is, they're interested in learning how you chose the server side as the starting point. So it's like a two-parter there.
I think that the server aspect of it was the problem we're trying to solve. The things that we're doing cannot be calculated on the client. So we highlight WebAssembly because it's like an interesting new part of what we're doing, but really what we're solving is a server-side problem. So it's sort of unrelated to what partners may be doing with WebAssembly on the front end.
I'll also add that Shopify, the Shopify platform also does provide some interesting and powerful solutions for front-end customization that aren't available on the back end. So, you may be familiar with Shopify's Liquid language to allow for theme customizations, to heavily customize the user interface of the storefront. There's also some really cool stuff. There's a particular technology called Argo that if you're familiar with Shopify's new subscriptions APIs, there's a really interesting piece of tech there to support similar levels of deep extensibility within Shopify's admin. Not based on WebAssembly, but based on similar properties, just more tailored to that use case. So I would encourage you to check that out as well.
Awesome. Okay, moving on to our next question. Can you make network calls from user-provided programs or scripts?
So at the moment, no. At the moment, you can't. We were considering potentially opening up this API eventually, but right now it's not possible. It has some limitation because we have to figure out how what we do around firewall rules and everything. Like what do we want to expose and what we don't want to expose to people. But it's something we've considered and we've been thinking about. But there's also the heavy performance requirements that we wanted those scripts to have. Given that they're all being run inline within our monolith, we want them to run really fast, and adding these network calls would introduce another layer of latency to our system. So we didn't consider them at first, but it's something we may open up in the future.
Yeah, and conceptually, you have to ask yourself, at what point do we just make the call and ignore the engine altogether? Really the whole point of it is to not make network calls.
Great. This is the next question's for you again, Maxime. Do you maintain dedicated execution engines per partner in order to scale based on the partner's needs?
So we essentially use a multi-tenancy model where every partner is hosted on the same systems, and we will eventually have a bunch of strategies to ensure that the load is balanced somewhat evenly and whatnot. But for now, we just have every partner contained within the same execution engine, and those virtual machines will just run the code of every partner's. And there's no really any distinction between which partner is who and what's being there. It's just a big sandbox where we run code.
Awesome, thank you. This next question is for you, Duncan, because it is kind of directly related to one of your slides. And the question is, they're a bit confused about the bottleneck communicating with partners. Is the bottleneck communicating with partner platforms? You mentioned some on one of your slides, there were some bottlenecks, and this person would like to know if they were related to talking to partners.
So sorry for the confusion. The bottleneck is the connection between the monolith and the code execution engine. So both things that are owned by Shopify within the Shopify cloud.
Great, thank you for that clarification. Mitch, this question is for you. Most partner apps have data as well as code. How is that handled if code is hosted at Shopify?
Yeah, it's a really good question. Couple ways of thinking about this. One is that currently what we're looking at doing here is small units of purely functional code to answer specific questions about some business logic in Shopify. In our current infrastructure, there is no way to sort of load up your own data as the person who wrote that. And so really we're working with pure functions. And that can solve a lot of use cases if it's just pure business logic or rules that we want to run inside of Shopify. And that can even coexist with your app that's running outside of Shopify as well. In the future, there's some great technologies within Shopify that allow partners to store code within Shopify's infrastructure. A really great one today is called Metafields, and Metafields allows an app to associate key value data with Shopify resources like products, customers, orders, and so forth. And so Metafields provides really powerful customization data solutions for the online store today. But maybe in the future, if this technology, if our assembly script APIs could access Metafields, that could be a possible solution there. So this is something that we think we'll invest in the future, and we'll look at what our options might be. But today, we're really just optimizing for pure functions. It's simpler. It still is highly valuable. And over time, we will add more and more powerful features. But that's kind of the current state of things today. So great question.
Thank you. Okay, the next question we're going for is for Maxime. What upcoming changes to WASM or assembly script do you think will make the biggest difference in our use case here?
I think for WASM specifically, like the interface type specs that is coming will probably help a lot with like making the interoperability between languages much easier. Because like right now we have our own way of communicating between those systems and like sharing data between those systems. But once that is kind of like spec'd out, it's going to be much simpler for other like languages, other kind of runtime to adopt, right? And it would be much simpler for us as well to adopt it as well and make it easier for people to use. For assembly script itself, like the language probably has a bunch of different features that would be nice. Like just thinking of closures would be one. Like there's a bunch of PRs and a bunch of work, and like Duncan has contributed to that. But like I think that would make the language much simpler to adopt and much more powerful. But it's a feature that's still missing to this day.
Awesome. And does anyone else have something to add before I move on? Or are we good? Okay. Okay, I'm going to throw this out to everyone, so just jump in with whoever has the answer. What trade-offs have you encountered by adopting the execution engine architecture, and are they worth the performance of WASM?
I can probably give it a shot at this one. I'm not like super sure because it could go in many different directions, but I think the performance trade-offs of WASM are pretty good so far. Like we've seen a lot of like our numbers are really good. If we were to compare to something like a long-lived service that runs on Docker, for instance, or like just a service that we would pipe data into that runs on Docker, would probably be much slower because there's a lot more different layers coming into play. And like we would have to figure out a way to actually like scale those different services. And it just seems like a very different architecture in general that would have been probably much more difficult to approach it. In our cases, like our use case is kind of simple, and like WASM has been kind of like a good barrier to entry for if that makes sense. Like it's simple for us to use for just the use case that we have, and we don't have to build like a whole lot of infrastructure around it. Like we essentially embedded a virtual machine, and we're able to run code fairly quickly and fairly securely as well. So it has a bunch of nice trade-offs. I think one thing that's kind of one kind of limitation that we had was the WASM module compilation. because it kind of limited a bunch of our approach that we had, because the compilation takes a little bit of time. And like we had essentially two different architecture that we wanted to have. Like one was in process and one was out of process. The in process approach was like we would have embedded the Wasm virtual machine into core directly, but that approach required us to like actually compile the module on every not every request, but like we would have to compile the module when there's actually a request made to it. And that compilation process takes a long time, and we weren't able to cache it efficiently, mainly because like there is so much web workers in Shopify core. There is so much different workers that would actually execute this code where the module would have to be loaded, and this kind of like caused a bunch of problems for us. Like we weren't able to actually cache these modules efficiently and actually achieve like our latency requirements, right? So I hope this one like answers it. It's kind of a difficult question to answer, but hopefully.
I'll add some context as well on the worth it question. So yeah, in the early days of this project, we actually did a number of prototypes with alternative technologies. We looked at different JavaScript execution VMs and runtimes. We looked at Google Functions, Amazon Lambda, and performance is where WebAssembly in this model kind of won very sort of profoundly. It was the most performant. There weren't cold starts. We could host tens of thousands of modules within a process. So it had a lot of these really amazing properties. Because of the criticality of the buyer checking out and that conversion that Duncan's mentioned in his slides, that absolutely is so important to Shopify. And Shopify is a very performance-focused company. We know how performance affects conversion rates. And so even though there are trade-offs to make with WebAssembly, it is a fairly young ecosystem. There's a lot of gaps in the developer experience. There's a lot of cool stuff coming down the pipeline. But for us, because performance is so critical, it absolutely makes sense, even if it means taking some shorter-term trade-offs. And the last thing I'll mention is that we, as a company, we have a lot of confidence in the future of WebAssembly. We're involved with other stakeholders in the community. We have lots of interactions with those working on the spec in different languages. And we're just really excited where WebAssembly is going. And, 3 years from now, 2 years from now, we just think it's going to get so much better. And, we'll be early adopters and the beneficiaries of sort of some of this early investment in the space.
Great. Well, we're already hyping people up for this because the next question is, can app developers use this now?
Yeah, I guess I can take that one. Not yet, but follow our blogs and our tweets and the various other resources that you have through the Shopify partner ecosystem, and coming soon.
Yeah, Shopify partners and developers will be all over this when this launches, so no one will not know about it, hopefully.
I will say that we are, it is in production to an extent. So it's not like we're talking about something that doesn't exist yet. It does sort of exist. It's just not released in that particular way.
Yeah, we are using this internally at Shopify to do a few things, to prove out the technology, to validate the developer experience, and so it is real, but it's not available yet for those outside of Shopify.
Maybe you need to join Shopify to try this stuff out. So there's a link to the career page, or you can just Google Shopify careers and you'll get to the career page. And we're hiring 2021 engineers in 2021. So that could be you. That's just my little short plug there, not planned, but I was like, might as well go for it. Okay, our next question is, how is dynamic partner data needed by the partner code handled? And that's up for anyone.
I believe I touched on this when I described.
Oh, okay.
All of these are pure functions. And so because they're pure functions, they always have the same input, and the code will always produce the same output. So there is no ability to do dynamic data yet.
Okay, so the next question I have is about accessing databases. So that doesn't happen either, I'm assuming.
Yeah, it's a similar answer, that we just aren't doing this yet, keeping our use cases scoped to pure functions and business logic. Over time, we want to look at this problem. We think there are other use cases that could be powered if there was this ability for dynamic data. And the reason we haven't looked at it is just because it's a significantly more complex problem. Not only do we provide untrusted code, but the ability to allow that untrusted code to read and write to data systems, that could introduce a bunch of latency. It really just opens up a lot of possible ways that this can fail. It is super powerful, something we want to explore, but right now we haven't looked too closely at this.
Great, thanks. Our next question is, does this mean that there needs to be a change on Shopify's backend servers to start communicating to the execution engine instead of the partner's web servers? And this is for anyone.
Yeah, I can take this one. So yes, but they're essentially two different things, right? Like you still have the app that lives on one side that can still receive webhooks and like apply a bunch of different transformations on the stores. But as part of this, you could deploy your script alongside with the app, and core would know how to execute those scripts. And so, yes, the backend needs to know that it needs to execute a script, but like it's all going to be integrated within how we actually execute them, and like how they're being deployed with the app, and how core knows how to recognize when to execute a script and whatnot, right? So it does, and it will achieve probably like there's going to be a few similarities. Like there's going to be some operations that are going to be similar to what the partners are already doing, and some of the capabilities are just going to be completely new because it's meant to extend some different parts of core, but some different parts of Shopify as well. And like the idea is to essentially provide those new functionality through those scripts. So there's going to be like some overlap and some differences in a few places, but they are still meant to be like compatible. That makes sense.
Great. Okay, moving on to the next question. Does running assembly script modules from Lucet have any implications for assembly script loaders and garbage collection?
I can take that one. So it doesn't, because our scripts are short-lived. So that means that everything that gets allocated will eventually be deallocated when the script finishes running. So one thing that it's not particularly important for a use case is the WebAssembly garbage collection spec. And on that same note, assembly scripts garbage collection capabilities are not, let's say, important for a use case either. So, and in that sense, in that same sense, the loader is not important either, because the loader, if I'm not wrong, it's intended to work as a standalone runtime. So yeah, those two features, they don't interfere, and we don't actively contribute to these features of the language.
Great. Okay, next question. Is it possible to deliver Wasab as a Sandbox JS module to the client side in the future?
I'm not sure if this question is, if I understand it correctly, but I'm assuming is sending WebAssembly modules to be loaded in JavaScript in the client. And I think we already touched on that before. Like, I think Duncan summarized this very well, saying that we are trying to solve like a business problem here. So we're mostly focused on the server side. So yeah, I guess that's my attempt to answer this question.
Yeah. Okay, that's cool. Next question again. Is your solution designed to run on an edge CND server? For example, there are efforts to do more computing at the edge, which should reduce some of the latency. So do you see leveraging that in the future?
So the current solution isn't built for that purpose. It's something we haven't really considered yet. It's probably going to like require like a completely different model to begin with to kind of support this. Something to think about, definitely, but I don't think we haven't I don't think we have considered this just yet.
Cool. And I think it's more of a Shopify monolith question than it is a scripts question, because we're sort of on the edge in that we're very close to the Shopify monolith, which is who's calling us. The client's not calling, the buyer isn't calling the script execution engine.
Okay, I think there is a follow-up question to Sam's question. Mitch, did you want to kind of recap what that is and introduce your answer? Thank you.
Yeah. So I think this sort of follow-up in relation to database access. So I'll reiterate that currently we're looking to solve use cases that just require customized business logic, which is based on non-partner facing data. And so I'll talk to it now because I saw the question asking for real world examples of checkout, which is a couple questions ahead. So I'll speak to that while I'm here.
Sure.
So an example of that would be, as the buyer's going through the checkout, we have this internal representation of the checkout object within Shopify. And so that object has, the line items, it has the products, the prices, all the data about those products. It has the total value of the cart. And so these sorts of properties are part of that checkout model. That checkout model is owned by Shopify. It's not owned by the app, right? It's part of our system. And that's the object that's sent to this WebAssembly module. So it is sort of dynamic in the sense that every checkout is different. Where the reason why it's different from partner data is because partner data is sort of this whole different beast, right? Shopify doesn't know what a particular app's database looks like or what data that app should care about. If it's a loyalty app, maybe there's data models around loyalty points and customers who have got those points. So all of these sort of data models that might exist in the app, Shopify doesn't know about. Whereas with an object like a checkout, we know what that looks like. We can give that to the module every single time and it's secure and we know the shape of that. So I think just wanted to touch on that dynamic data question, but knowing that the purpose of these modules right now is pure functions for customized business logic. Again, there is a limitation where you can't access your own data store, which could prevent certain types of use cases for sure. But that is something we will explore in the future to see, if that app developer, if that WebAssembly had access to a data store that was owned by the app, what kinds of use cases will that enable? Could you do more powerful business logic? Could you create more powerful Shopify apps? And I would say then sort of maybe the intermediary step along that path is looking at things like metafields, because metafields is an existing partner-facing key value store. Apps can write a lot of data into metafields that Shopify doesn't have to deeply understand. And so maybe that's the next step. But as far as a full database, there's just so much complexity there around performance and security that it'll be probably a while before we look to there. But yeah, hopefully that. Just going to scan the questions to make sure I answered it. But
yeah, Sam's come back with a follow-up about the client consuming WASM business models made by Shopify. Is that possible, or will be possible? Maybe the server or client.
When we say client, I guess Sam, do you mean so you mean the web browser client or the mobile client, not the customer, I guess, of Shopify? Yeah, I think. Maybe it was Duncan that answered this earlier, that today we're focusing on backend use cases because today there's already a lot of great tooling to customize the online store. Whereas on the backend, there's less ability to do this kinds of deep customization. So there may be a world in the future where the same snippets of business logic execute in both places. But because there is the ability to implement that logic potentially on the theme as well, we're not focused there. So yeah, I would say right now, backend focused, theme customization is the best way to handle front end online store customizations right now.
One thing that I'll maybe add that I'm not sure if it's clear yet is that scripts are configurable. So a partner can configure their script so it doesn't run. It's not going to do the same thing on every input every time. It's dependent on configuration. So in terms of real world examples without accessing dynamic data would be something like discounting, creating complex promotions. Would be one example. You don't need to access data. You just configure something and then it's a function of the checkout.
Great, thank you. We seem to have people that are really chomping at the bit. They want to know when the beta's coming out.
Same answer. I would say keep watching things. We are talking more about this. We've been working on it for a while. So we are as excited as all you are, I'm sure, to get this out there into our developers' hands, and we're working as hard as we can to make it happen. Stay tuned.
Coming soon. Okay, we are at 4 minutes. Sorry, somebody just sent me a message complimenting on my dress, and I'm really kind of embarrassed and happy that it's happening. Thank you so much. We have like almost 3 minutes left. We've got one more question to go, and then we'll wrap it up. There was a lot of stuff going on. There's a video of this going to happen afterwards, so if you miss things, don't worry, you can watch it again. So here we go. Is there any non-database way to handle state?
No, they're not stateful. It wouldn't. Anything that we could do in the short term to add in state would not work the way you would want it to.
Yeah, the only thing that I would add to that too is to remember that they're short-lived because they need to execute synchronously. So adding a state kind of implies adding a bit of delay, and that would just, not meet the purpose. So.
Okay, we're gonna wrap this up unless you guys all have like something you want to leave the audience with.
I mean, thanks everyone for coming. Yeah, we're excited to share this, and yeah, we'll do more of these in the future, hopefully, and find different ways and better ways to interact with the community. And as we approach some kind of a beta, like, you'll be the first to know, or be sure to follow our various partner-facing communications, and yeah, lots to come.
Awesome. Okay, so we want to thank you all for joining us today. We will have a recording of this video available for you, and everyone who signed up for the event will get an email with this, and it'll also be embedded in the WebAssembly blog post, and it'll be on our YouTube channel. I will send an email out. In that email, there'll be a survey. We want to know what you like, what you don't like, what you want to see. Takes very few seconds to fill it out, so please give us that feedback. Our next event is on March 31st, and we're talking about faster CI. So if that's something that interests you, developer tooling, please tune in, follow our Twitter account, or sign up for the mailing list to get first dibs on when that information will be out. We're hiring 2021 engineers in 2021. Head to the career page and see some open roles. Join our LinkedIn network engineering group, and you can find out more information about our careers. Finally, thank you all for joining us and spending this hour. Thank you to our guests. I hope you guys had a good time, and that the questions were really fun for you to answer, or maybe a bit torturous. Who knows? I kind of like both ways. So I hope you have a good afternoon, and we'll see you on the next one. Thank you.